Animals that live in aquatic environments often have to cope with conditions where visibility is drastically reduced. As a result, many animals have developed other sensory systems to supplement vision. One such example is sonar. What sensory system seals and other pinnipeds use has previously been unknown. It was hypothesized that harbour seals could use their vibrissae, otherwise known as whiskers, to detect hydrodynamic waves left by fish. The aim of this experiment was to find out whether Phoca vitulina, otherwise known as harbour seals, could locate distant objects by utilising hydrodynamic trail following, as seen here. The experiment was conducted at a German zoo in an outdoor pool filled with seawater. A miniature submarine was used as the fish to create the trail, as it leaves trails similar to that of the fish. Its heading was chosen pseudo-randomly each trial. A male harbour seal called Henry was the main test subject throughout the various trials. The seal was originally trained to find the submarine without any sensory restrictions at all, and gradually this was made harder by inhibiting his senses one at a time, until he was only relying upon hydrodynamic waves to find the submarine. This was achieved through covering his eyes with a visually opaque stocking mask, then attaching a pair of headphones to his ears and only removing them 2 seconds after the engine of the submarine had been turned off, in order to mask any acoustical hints. Finally, having the seal's head 40 centimetres above the water surface in a hoop station until he was allowed to start searching was to prevent any potential sensory cues he may have been receiving. Once the seal was allowed to begin searching, it immediately submerged and protracted its vibrissae as far forward as possible and made slight lateral movements characteristic of hydrodynamic wave detection. This continued until the seal detected a trail, at which point it would turn directly onto the submarine's course and track it back to the submarine. In this first test, the seal was able to locate the submarine 256 out of 326 trials, which gives it an accuracy rating of 78.5%. In the remaining 70 trials in which the seal failed to locate the submarine, 56 of them were due to the seal missing the start of the trail, and only 11 times the failure was due to the seal diverting from the correctly tracked trail. The next test was developed to replicate a more natural environment. This was specifically in regards to the way that seals in the wild would need to be able to detect a fish's trail and what direction it was travelling at any given point along it. To replicate this, 50 more trials were conducted with the submarine running parallel to the side of the pool, therefore passing the seal's hoop station at a distance of 1 metre. During these trials, the seal was able to correctly locate the submarine in 46 out of the 50 trials. In each of these tests, interspersed throughout the trials, was a restraint test, meaning that the test was the same in every way, except the seal had his muzzle and consequently whiskers covered by a stocking mask and would therefore be unable to detect any hydrodynamic waves. In every one of these 30 tests, the seal failed, thus proving that it was using its whiskers alone to locate the submarine. To ensure that this ability was present in all harbour seals, a second harbour seal named Nick was tested also. His scores corresponded almost exactly with those of Henry in every aspect of the tests. The result from these tests showed that hydrodynamic wave detection can successfully explain the feeding of seals and possibly other pinnipeds in dark aquatic environments where other senses may be compromised.